Thank you for being a part of the class today. Here we are going to be looking at um, heat capacity and specific heat capacity. And before we do that, I want to urge you that if you have not subscribed, make sure you subscribe, and then so that you will always enjoy our subsequent video that will be coming on. Here we have some things we're going to look at on the board. Here we have the heat formula. You know that heat formula is what? Q, M, C, and delta theta. That is to say, where Q is quantity of heat or energy, we have M as what? The mass of substance, and then C as what? Specific heat capacity, while delta theta is what? Change in temperature. So for us to get the quantity of heat, all these things must be applied. Once you multiply them, you get your quantity of heat or energy. Now we already know that energy is what? Heat is a flow of what? Energy. So in other words, heat is a form of energy too. So in this case, we look at another one of the parameter we always consider whenever we're looking at heat is one of them is what we call the heat capacity or thermal capacity, which is the heat. This is the quantity of heat required to raise the temperature of a body by 1 degree. So which means the quantity of heat that we require to raise the temperature of a body by 1 degree. So again, thermal heat capacity has a unit. The SI unit for it, the SI unit is joule per Kelvin. Joule per Kelvin. So another parameter we always talk about is specific heat capacity. This is the quantity of heat required to raise the temperature of a unit mass of a body through 1 degree. Now you note something here, talking about a unit mass of any substance, a unit of it. That means that's why we say it was specific. It's talking about a particular mass. Why the other one, why the thermal heat capacity has nothing to do with the mass, just the increasing the body temperature of a substance to 1 degree. So, but then when we talk about specific heat capacity, always know that it has to do with a unit mass of any substance is dealing with. You know, I believe that's the ability of that quantity of heat to raise the temperature of that unit mass of substance to that what 1 degree, which is not quite different from what we have in thermal or heat capacity. Now, also the unit, the SI unit for specific heat capacity is joule per kilogram per Kelvin. And then for us to calculate the thermal heat capacity, we will require this formula where M is equal to what? Mass, and then C is what? Specific heat capacity. Specific heat capacity. Specific heat capacity. That's just what we need. All right. And another one we're going to be looking at the how to find the specific heat capacity of any substance. So we have two methods of calculating specific heat capacity. One of this method is what? Mixture method, and the second one is electrical method. In mixture method, a hot object can be added maybe to a liquid. When you mix it to a liquid, you record the temperature change, and then using the heat gain, since we know that the quantity of heat is, as well we have already stated, is this: the quantity of heat supply from the hot objects and to the other substance that we want to find out the specific heat capacity. We can just mix it like this, and then we will be able to get it. And in that case, knowing that the quantity, let's say that the quantity of heat is coming from another substance, we can say maybe copper. We know that we know the mass of the copper, and we know the specific heat capacity of the copper, and then we have the quantity of heat that temperature change there. The temperature change now, temperature change of the copper will be equal to, perhaps this one is water, and the temperature change too, change in temperature. So the heat lost by this one is the same heat that is gained by the water. So by adding up the whole of this thing, by using this formula, this one stands for the quantity of heat, and then the other one mass of the water and specific heat capacity of the water and temperature change, making specific heat the subject of the formula. We will have something that will look like this: quantity of heat over what, mass times change in temperature. So this is what we have. With this now, we'll be able to get the specific heat capacity of the water. In the electrical method, so under electrical method, all this will give us a quantity of heat supplied by the electric current, where we have I is what is the current, V is the voltage, T is the time taken for the flow. Where you have voltage and resistance, you can also get it by voltage square over resistance multiplied by what, time. You also get your what, quantity of heat. And also where you have resistance and current, you can also do that by current square resistance times time. With all these things, you'll be able to get the quantity of heat. And in that case, where we have the quantity of heat to be mass over specific heat capacity, perhaps of water, and change in temperature. With this again, we can also make the specific heat capacity of the water the subject of the formula. We will have it to be like this. So with this, you can also get what you want, where this Q can be either of these, any of them, or as well, you can also look at it the other way around, where we have it to be that. So all these things will arrive at the same thing. So thank you so much. In our next video, we are going to be showing you, make sure you visit the template, the playlist, the playlist, in the playlist, you'll be able to see some other calculations that will be coming up in regards to each of these things you have here, and how we can also calculate the specific heat capacity based on the electrical method and also the mixture method. Thank you so much for coming this far. We're happy to have you. I hope you enjoy your stay with us. Thank you.